In today's video, we are going to go through the remainder and factor theorem. You may remember this from your add math classes in Form 4 and 5. However, I know things get a little cloudy as we grow up. So today we are going to go through in a little detail the remainder and factor theorem because in our Keep Pure Mathematics Unit 1 paper, we also come across these questions. Polynomials. So before we get into the remainder and factor theorem, you know I have to go through some fundamental concepts. And this is where polynomials comes in, because the understanding of this can definitely help in our understanding of the actual theorems and where they come from, the basis of them. Okay? So poly means many and nomial means terms. Poly, you know what I mean. Polynomials, okay? So many terms. However, the name can be kind of misleading because polynomials can also just have one term. And that's where the name monomial comes in, or monomial, okay? So polynomials, there are many types. Some include monomials, binomials, trinomials, and quadrinomials, and quintinomials. And of course, that's a bit extra. We don't really need to know these things, but it's still good to know them. So polynomials, the actual polynomial consists of constants, variables, and exponents, as we'll see in our examples. So here's a list of some examples of polynomials. So the first one, as you know, I said polynomials, although it means many terms literally, some can only consist of one term. So this is a polynomial despite the fact that it is only one term. It's a monomial, right? So a constant is still a polynomial. It does not need to have a variable. However, it can. So this is also a polynomial. And these two kind of fit the definition. So it's quite obvious. Right. Moving on to the degree of a polynomial. So the degree of a polynomial is simply the highest power of x in the polynomial determines the degree. Okay, so let's take a look at this example. The polynomial 5x to the power of 4 plus 7x minus 3 is of degree 4. Why is it of degree 4? Because this signifies the power, you know that, right? So the exponent. We went through that in the last video, or the order, right? So since this is the highest, this would be 1, right? This is the highest, 4 is the highest. That is why it's of degree 4. So if this was 5x to the power of 4 minus 7x to the power of 6 minus 3, we would now notice that 6 was the highest, and therefore that polynomial would be of degree 6 rather than 4. So all it has to have is the highest power of x, and that determines the degree of the polynomial. So if we look at the second example, the polynomial 2x cubed plus x minus 1 is of degree 3, exactly, because that is the highest power, that is the highest power in that polynomial. Right. So similarly to how we deal with normal numbers like 1, 2, 3, 4, 5, minus 5, things like that. Similarly as to how we would deal with them, polynomials can be added, subtracted, multiplied, and divided, just like how we would deal with normal numbers. Okay? Now we move on to actually evaluating polynomials, and that means kind of finding a value, okay? So polynomials, if we were given, looking at this example, if we were given f of x is equal to 3x squared plus 5x minus 7, and we were asked to evaluate it, we were given to find f of 1 and f of minus 3, we would simply substitute x to be 1 in this case, and x to be minus 3 in this case, and substitute it and then solve, okay? Meaning evaluate it. So we simplify this, end up getting 1, simplify this, end up getting 5, and that's all it means. So evaluating polynomials involves substituting values for the variable in the polynomial, simplifying and getting the answer. Right. Comparing polynomials. Don't worry. If the corresponding coefficients of two polynomials are equal, then two polynomials are equal. Let's look at an example to further understand what I just said. The example states to find the constants a, b, c, and d. So that's a, b, c, and d here. Given that this is equal to this. Okay? So we see that we need to find these values, and all the information we were given is that this is equal to it. Okay? What we have to do is somehow put that in a way, a state in which we can identify that they have similar values. So if we were to get it into a place or in a state where they had x cubed, x squared, x, and then a constant, right? We can, because as you know, if we were to expand this side, the left-hand side, we can get it, and you'll see. So all we would do, if we would ask something like that, we would expand, and then after expanding and getting the x cubed, x squared, x, and the constant, we would compare the like terms. So let's do that. We would start with the left-hand side, which is this, the left-hand side, and we would forget the right-hand side right now. So we would work with the left-hand side and expand it. So we begin here, and note that you can start with these two, or these two, or even if you wanted to multiply these, I don't know how you would want to do that, you can, and then multiply it by this, and you would get the same thing. It's the same idea, right? So I expanded. I know some people jump and get here to here in one step, but I think for me, it's a lot easier, and I can break down if I did something wrong, because I like to recheck my work in and just to make sure everything's in the right position and I did everything correctly. So I would do all my work in. However, if you wanted to, you could just jump. It's fine. But you would notice that we have x cubed, x squared, x, and 6, which is similar to this, right? Exactly. So that's how we are able to now say, okay, remember, it's given that they're equal. Okay, so it's not an assumption we make it. We know that this is equal to this. So this is equal to this. And now, since this is just this, but in the expanded version, we are now able to say that this, now the updated left-hand side, is equal to this. We can equate them, which is what we're going to do now. So since this is equal to this, which is what we were given above, and now this is our expanded version, we will now say that it is equal to the right-hand side. Okay? And now we can compare like terms in order to get values for our constant, which is what they asked us to get in the question, right? So we know x cubed. Remember, let's go back to the kind of definition. If the corresponding coefficients of two polynomials are equal, then the two polynomials are equal. Okay? So let's look at the terms. We know that x cubed and x cubed. So it only makes sense to equate them, right? So now we can come up with a value for a, b, c, and d, and that's exactly what we did. This would be equal to this because it has the same coefficient, right? I mean, we have the same terms, so x cubed and x cubed, and then we can compare the coefficients and then equate. So a will be equal to 3, b would be equal to 8, and note this, the sign has to be taken into consideration. So this is a minus 5, and this is a minus 6, and hence c is equal to minus 5, and d is equal to minus 6, because there's a negative sign in front of it. So you always take that into consideration and be very careful with that. So yes, that is how we would work with a question in which we have to compare polynomials to find the answer. The factor theorem. But firstly, what exactly is a factor? By definition, a factor is a number that divides into another number exactly. So that means it does not have a remainder. There is no remainder. Okay? So the factor theorem states that x minus alpha, alpha being a variable in this case, a placeholder for a number, is a factor of a polynomial f of x if and only if f of alpha is equal to 0. So what we would do is substitute the number into the polynomial, and if it is equal to 0, then x minus alpha is a factor. So let's look at that and have a better understanding when we look at this example. This example states to determine whether or not x plus 2 is a factor of the polynomial, and they give us the polynomial, right? So let's see, how would we begin this? The first thing we have to do is find x, okay? Because we have to substitute that into the polynomial and then see if it is equal to 0 or not. So the factor in question, x plus 2, we have to equate it to 0 and get a value for x, okay? So x plus 2 is equal to 0, so x would be equal to minus 2, okay? If x plus 2 is a factor of f of x, now we know minus 2, then f of minus 2 would have to be equal to 0. If it's not equal to 0, then x plus 2 is not a factor. So the next step would be to actually substitute minus 2 into the polynomial. Remember, this is it. We would have to substitute x is equal, x being minus 2 into this. And if it's equal to 0, it's a factor. Okay? So f of minus 2 is equal to minus 2 all squared, which is 4, plus 3 by minus 2, which is minus 6, plus 2. And then we know 4 minus 6 is minus 2, plus 2 is 0. So since f of minus 2 is equal to 0, x plus 2 is in fact a factor of f of x. And that's exactly how we would approach a question like this. Now, stated a little differently, this question tells us that this is a factor, but it doesn't say so exactly. You have to come to that conclusion. So, for what value, okay, this states, for what value of k is q of x, remember this is just a placeholder for a polynomial, this is the polynomial, exactly divisible by x minus 1. So for what value of k is q of x exactly divisible by x minus 1? Exactly divisible by x minus 1 simply means that x minus 1 is a factor, okay? You have to be able to know that. So this language means that it's a factor. If it's exactly divisible, it's a factor. If you go back to the definition of a factor, you would understand what I'm saying now. So we know for sure it's a factor, and we have to use that information in order to come to the conclusion of what k is equal to, okay? So it's asking us, for what value of k is q of x exactly divisible by x minus 1? So we would begin the same way we began the last question, and we would find the value for x, and we would notice that it would mean q of 1, because we found the value of x, q of 1 is equal to 0 because we know that x minus 1 is a factor, okay? So by the factor theorem, q of 1 would be equal to 0. So now, let's actually substitute it into q of x, okay? So x is equal to 1 basically. So when x is equal to 1, we will have to substitute it into this polynomial. And remember, the final thing we have to come to is getting a value of k itself. So let's get there. If we simplify this, we would get to 7 minus k. And remember, q of 1 is equal to 7 minus k now. And we know that q of 1 is equal to 0. So that means 7 minus k is equal to 0. And now we simply solve for k, because 7 minus k is equal to 0. And we know that k would be equal to 7. So it asks the question, use the factor theorem, but it just simply was stated in a different way, and you had to be able to kind of understand everything in order to come to that conclusion. So although the terminology was slightly different, it meant the same exact thing. So it's kind of a trick, okay, in that sense. So yes, that is how we would use the factor theorem to solve a question like this. The remainder theorem. The remainder theorem states that f of x gives a remainder of f of alpha when it is divided by x minus alpha. Okay, So there are two ways in which we can approach a remainder theorem question, or a question that involves using the remainder theorem. The first one is long division, and the second one is substitution. I have no idea why you would ever want to use long division to solve a question like this, but in the case that you are one of these peculiar children, I will show you how. So let's look at an example. Find the remainder when 8x squared plus 5x plus 1 is divided by x minus 1. So like I said, there are two ways in which we can solve this. The strange way and the right way. So the strange way being long division and the second way being substitution. Okay, so let's go through the long division for some of you. Okay, so remember the question, find the remainder. All we have to do is find the remainder when this is being divided by this. So of course you know there's a divisor and there's a dividend. So this will of course be the dividend and the divisor. The remainder would be what's left, and this would be the kind of quote-unquote answer, or the quotient. Okay, you might remember all this from primary school, but let's go through it now. So the first thing we would do, remember, none of this exists yet, okay? We would only start off with this section right here. And the first step is to divide the first term in the dividend. So we would look, this is the dividend, and we kind of want to get rid of it term by term, okay? So we would look 8x squared, we would look at 8x squared and say, okay, how many times can x minus 1 go into this? So at this point, we're not really looking at the minus 1. We would say, okay, x is the first term, and we'd say, okay, how many times can this go into this, okay? And we know that 8x multiplied by x is 8x squared. So that is why we would put 8x times. So the 8x would go on top here. Then the second thing we would have to do is multiply. So 8x by x minus 1, we have to go by the entire thing. So we have to multiply by the entire divisor. So it would be equal to 8x squared minus 8x. So this is what we did on this side here. This is just for clarification. And we would subtract it. So since the terms have the same sign, we subtract. The purpose is to eliminate the first term. Okay? So 8x squared minus 8x squared minus 8x. So basically subtracting this from this. And we would say, okay, we would do this just like that. So we would bring this down, and we'd say, well, we don't bring this down yet, but you can. I always do. I know people do it after. So we would say 5x minus 8x. That's also tricky, right? So since it's minus and minus, that automatically turns into a plus. So 5 plus 8 is 13x, and then this crosses out this. And that's exactly what we had to do, right? So we did a good job there. Then we ended up with this, okay? So first thing we would do, bring down the remaining terms, but I do that first. You can do it either way. So that would be step 4, bring down the remaining terms. Whatever is left, just bring it down, okay? So we would end up with this, which is here, okay? And now, the final step, can the divisor, being this, go into what is remaining at the time, okay? So since this is remaining at the time, yes, it can, because 13, we can put 13, right? And that's exactly what we did. 13x minus 13, so we would have to, because we put 13 on top here, we have to multiply that by this, and then simply get this, and then simplify. Okay, so then we end up with a remainder of 14. And at that point, if x minus 1 can't go into 14 anymore, then this would be the remainder, which it is, because x minus 1 cannot go into 14, and hence it is the remainder. Okay? So these steps you just go through over and over again until there is a remainder, or if it's 0. Okay? So if there is no remainder, it's equal to 0, right? So if 0 is here, which is usually the case, but we found the remainder, which is what the question asked for. So we had to find the remainder when this is divided by this, and that's what we did. So when 8x squared plus 5x plus 1 is divided by x minus 1, we get a remainder of 14. 14, why? Because the divisor can no longer go into the remainder. And that's why it is the remainder. Okay? So now the more sensible way of going through a question using the remainder theorem is substitution. You can, of course, do either way. I just highly recommend you do this one because why wouldn't you? You know, after I go through it, you'll understand why. So let's go back to the actual remainder theorem. F of x gives a remainder of f of alpha when it is divided by x minus alpha. Okay? So what we're doing here is simply solving for f of alpha, and that's equal to the remainder. And it makes more sense, right? I mean, either way, it's easy. This is also really easy once you get the hang of it, but I think if you don't remember it, don't bother with it. I mean, of course, you still should learn it because you should learn everything. You should be open to learning anything. But I think in the exam, this might be a bit easier to go about. So, of course, we have the polynomial, and when f of x is divided by x minus 1, the remainder is given by f of 1. Right? Because x minus 1 is equal to 0, x is equal to 1. So f of 1, and then now we solve for f of 1. So to do that, x is equal to 1, substitute x is equal to 1 into this, and whatever is remaining, when we simplify, is the remainder. And notice we got the same 14, and all we did was substituted a number and simplified it, rather than going through this entire process. I mean, it's not a... I feel like I'm exaggerating. I really am exaggerating because this is not hard at all. It's just if you don't already know it, don't bother with it, okay? But yes, that's how you use the remainder theorem to solve a question. Now onto our favorite chapter of the video, the past papers. We'll be going through 2021. 2021 states the function f of x is divisible by 2x minus 1. Immediately, divisible by 2x minus 1. This terminology, what does it mean? Remember, this means that 2x minus 1 is a factor. So immediately think that. That is exactly what should be going through our minds when we read that. So no, I just want you to know that this is what you need to think of. Immediately, as soon as you read that, think, okay, it is a factor. The factor theorem must be applied there. Okay, so 2x minus 1 is a factor. So transpose to get x. We get x is equal to a half because 2x minus 1 is equal to 0. X is equal to a half. Okay, and from there, f of a half is equal to 0 by the factor theorem. Okay. And then has a remainder of minus 5 when divided by x plus 2. Again, immediately, what should we be thinking? Okay, remainder theorem, they say it's a remainder of 5 when divided by x plus 2. So x plus 2 is equal, when x plus 2 is equal to 0, x is equal to minus 2. So now we know f of minus 2 is equal to minus 5. We came to that conclusion already. That's exactly what we need to be thinking of at the point when we read the question. We don't have enough time to say, oh, what does that mean? We need to know that is exactly what it means, and that's where we need to start. Okay, and just a little heads up, we use the factor theorem and remainder theorem to get two equations. And when we get these two equations, we need to solve them simultaneously in order to get the values of a and b, which is ultimately what they are asking us for, to calculate the values of a and b. Let's begin. We start with the first part. We actually state what the function is, okay? So they give us this polynomial, and they say, okay, calculate the values of a and b given the information, this information, right? So we'll use the first set of information first. Remember, we already came to that conclusion, but this is just me writing it out. Okay, so we came to the conclusion, we transpose to get x, and we said, okay, by the factor theorem, f over half is equal to 0. Now we actually get what f over half is equal to. So is equal to a over 8. But to get this, we simply substituted x is equal to half into the function itself, right? And we know that since f over half is equal to 0, we can equate this to 0. And this is how we simplify and end up with our first equation, right? So now the remainder theorem comes in to get our second equation. So we read this piece of information, and we say, okay, that means that we need to get the value of x, which is minus 2, and f of that value, minus 2, is equal to the remainder 5, minus 5, right? So now we simplify what f of minus 2 is actually, the actual value for it, and then equate that to minus 5. So minus 5 is equal to minus 8a plus 12 minus b, right? So b plus 8a is equal to 17. Okay, so, and then, because we can no longer simplify this any further, we say, okay, that's equation 2. So now we have both our equations. We will now solve them simultaneously. Right. To do that, remember, we can solve equations simultaneously in two ways: elimination or substitution. I usually do elimination, however, substitution can be a lot easier in some cases. But let's do elimination for now. So 8b minus a is equal to 6 is equation 1, and b plus 8a is equal to 17 is equation 2. So what I would do is try to get at least one of these terms with the constants in them to be alike. So I would multiply this entire equation by 8 just so I can get 8b to be equal, and then we could subtract them in order to eliminate, that's where elimination comes in, an entire variable, okay? So when I multiply this entire equation by 8, I get this, equation 3. So I multiply this by 8, this by 8, and this by 8 to get 8b plus 64a equal to 136. So equation 3 is simply a manipulation of equation 2, so it still counts. Now using equation 1 and 3, we subtract them. So I'm subtracting this from this. So 8b minus 8b, I eliminate that entirely. So that entire variable is gone, and that was my goal in the beginning. Okay, so I reached my goal, and now I just solve for a. Okay, I end up with minus a minus 64a. So I'll get minus 65a is equal to 6 minus 136, which is equal to minus 130. So if you couldn't do mental math really quickly, plug it in your calculator and get the answer. Okay? Substituting a is equal to 2 into 1. Now that we have a value for a, we simply substitute that into either these equations. I chose 1 because it was easier. A, right? You won't have to multiply it by 64 and then simplify. So 8b minus 2 is equal to 6. This is what I get here, right? So I substituted a into this one only because it's easier. You can substitute it into this one too, or even 2, because remember, this is simply a manipulation of this, so it's technically the same thing, right? So when I got my value for a, substitute it into any equation, solve for b, and there we have it. Remember, that was our goal, to get the values for a and b. And that's how we do it. However, I just want to look at if I were to use substitution instead of elimination. Let me show you. So I would have said, okay, I have a positive b, so I would transpose b would be equal to 17 minus 8a. Then I would just substitute this b into 1, and I would get 17 minus 8a minus a is equal to 6. I think that should be it. Yeah, I would do that and then solve for a. When I get a value for a, substitute it into equation 1, and then that was all I had to do. And then I would get these two values. So yes, maybe substitution would have been easier there, but I just did elimination because that's what I usually do. So it was what I was more comfortable with, and when you get the hang of it, you can decide what's more comfortable for you. The second past paper we'll be going through today comes from 2017, and this states that the polynomial f of x is equal to ax cubed plus 9x squared minus 11x plus b has a factor of x minus 2. Right there we stop. Has a factor of x minus 2. That right there is direct language. Okay, so that's telling us that f of 2 is equal to 0. Okay, so the first thing when we see that, is say, okay, so x minus 2 is equal to 0. So that means x is equal to 2. Okay, and because it's telling us that it is a factor, for sure, we can say that f of 2 is equal to 0. So that means when we substitute 2 into the polynomial, it's definitely going to be equal to 0 because it has a factor of x minus 2. Okay? Now the second piece of information says, and the remainder of 12 when divided by x plus 2. That's our second piece of information. So x plus 2 is equal to 0, and we can say x is equal to minus 2. So now we can come to the conclusion that f of minus 2 is equal to 12 by the remainder theorem. Okay? So all we did was read the question and we came to two conclusions, which is all we need to solve this entire question. So ultimately, we have to show that a is equal to 2 and b is equal to minus 30. So notice they actually gave us the values and we don't have to go searching for them. So we know exactly what we have to get in the end. Let's begin. Using the first piece of information, we can say if x minus 2 is a factor, f of 2 is equal to 0. So remember, we came to that conclusion already. That was the first one. So let's evaluate f of 2. To do that, we simply substitute 2 into wherever we see x in this. Let's do it. Now that I've substituted x is equal to 2, I can say it's also equal to 0. This here is equal to 0 because f of 2 is equal to 0, and this is f of 2. Okay, so let's do it. Let's simplify now. So this will be 8a plus 36 minus 22 plus b. Exactly, right. Now let's make this an equation. To do that, what I would usually do is I would put the variables to one side and the constants to the right side. So this would be 8a plus b is equal to minus 14. Okay, and I'll make this equation 1. Cool. Now moving on to using our second piece of information, which comes from the remainder theorem. So they say the remainder of 12 when divided by x plus 2. So that means that f of minus 2 is equal to 12 by the remainder theorem. Right, now let's evaluate f of minus 2. So we do the same thing, but instead of substituting 2, we substitute minus 2 wherever we see x. So let's do that. Okay, so now let's evaluate. So I'll simplify. And now, all of this is equal to 12, because remember, by the remainder theorem, this is equal to 12. And therefore, this would be equal to 12, because this is this. That's what the equal sign means, right? So, let's make this our second equation. Like I said, I would put both variables on the left-hand side and the remaining on the right-hand side. Now that we have two equations, we can do some magic, and it's called simultaneous equations.
solving equations simultaneously. So now that we have both of the equations, this is what it looks so far. Let's solve them simultaneously to get our values for a and b. So I used elimination before, let's use substitution now. I simply made b the subject of equation 1, b of equation 1, the subject, and then I get minus 14 minus 8a. And now I'm going to substitute that into equation 2. Okay, so wherever I see b in equation 2, I would put this. Okay, using b from equation 1, I would substitute it into equation 2. So it would look like this. I'll put this in brackets. Minus 8a is equal to minus 46. Right? So this is how it would look. And now we simplify. And then we would get that a is equal to 2. Now that we have a value for a, we simply substitute that into equation 1 or 2, whichever one you think is easier. So I'll just substitute it into 1. And now I will simplify. And there we have it. Remember, our end goal was to show that a is equal to 2 and b is equal to minus 30 using the information given in the question. And notice a is equal to 2 and b is equal to minus 30. And there you have it. That is how you solve questions using the remainder and factor theorem.